Good morning, ladies and gentlemen. Our week in review. We will conclude our topics on equations, and on Friday we will transition to the introduction to transformation. Next week we will continue our unit on transformations, and we will have our first quiz on October 16th. So the way that we perform basic matrix operations using multiplication is a process called scalar multiplication. Scalar multiplication is nothing more than the process to multiply each element by real numbers. Element, the value inside a matrix. We see this symbol. We know that the numbers these values inside the matrix are called elements. In order to determine for addition and subtraction, we also look at rows by columns. Rows we identify across, columns we identify up and down or vertically. So the dimensions of this matrix would be a 2 by 3. 2 rows by 3 columns. With scalar multiplication, you will only see one matrix and a value outside the matrix. So we're increasing all of the elements inside the matrix. If we're multiplying by a whole number, let me restate that. We're simply going to multiply the value inside by all of the elements inside. 2 is multiplied by -1. 2 is then multiplied by 0. 2 is multiplied by 3. 2 times 6. 2 times 5. 2 times 2. This is what it looks like when you apply this process on paper. You should be following these steps on paper. 2 is multiplied by the -1 that you see above. 2 is being multiplied by 0. 2 is being multiplied by 3. And we follow this process for each element or each value inside the matrix. So 2 times -1 is -2. 2 times 0 is 0. 2 times 3 is 6. 2 times 6 is 12. 2 times 5 is 10. 2 times 2 is 4. This is the solution when I multiply matrices. It's called scalar multiplication. So again, a review of addition and subtraction. We want to look at rows and columns. Identify the dimensions first. Rows, 1 row, 2 rows. Columns, 1, 2. So the dimensions, again, we identify rows by columns. Rows by columns. So here we have 1, 2 rows. by 1, 2 columns. This would be a 2 by 2. Again, we have 1, 2 rows, 2, 1, 2 columns by 2. If the dimensions are equal, we can subtract. If the dimensions are not, the answer is undefined. So here, we now line up the elements or the numbers inside the matrix. Negative 11 and positive 7 are the two values that we add first. In order to remember how to do this process, write them in a separate matrix and then perform the operation indicated in the middle. Negative 11 minus 7. Then I move to the next two values. 9 minus a negative 1. Then I move to the next two elements. 4 and negative 16. 4 minus negative 16. Last, negative 20 and 0. Negative 20 minus 0 equals 11 minus 7 is negative 18. 9 minus a negative becomes positive. 9 plus 1 is 10. 4 minus a negative is plus. 4 plus 16 is positive 20. Negative 20 minus 0 is just negative 20. My solution. So back to scalar multiplication. Again, the values inside the matrix are called elements. In order to find the solution, I multiply 2 times all of the elements. It's similar to the process of distribution. Again, I say it is similar. Everything inside the matrix is multiplied by the value outside the matrix. I rewrite. Remember that I should have an equal number of values inside because I'm not changing the number of elements inside the matrix. So I have 2 times negative 1, 2 times negative 1, 2 times 0 times 0, 2 times 3, 2 times 3, 2 times 6, 2 times 6, 2 times negative 5, 2 times 2. 2 times negative 1 is negative 2. 2 times 0 is 0. 2 times 3 is 6. 2 times 6 is 12. 2 times negative 5 is negative 10. 2 times 2 is 4. And again, the position that they are in stays the same. So for example 2, we have a fraction outside the matrix. With basic matrix operations, when we multiply, you just need to remember the rules for multiplying fractions. So again, -1/4 is multiplied by everything inside the matrix. So I would have -1/4 times 1/2, -1/4 times -2/5, -1/4 times -12, -1/4 times 3. Negative times a positive is negative. 1 times 1 is 1. 4 times 2 is 8. So I have -1/8. Negative times a negative is positive. 2 and 4 simplify. I'm left with 2 and 1. 1 times 1 is 1. 5 times 2 is 10. -1/4 times -12. I rewrite these both as a fraction. 4 goes into 12 3 times evenly. Negative times a negative is positive. +3. -1/4 times 3. Again, I write it as 3/1. Negative times a positive is negative. 3 times 1 is 3. 4 times 1 is 4. This is my solution. Remember, with scalar multiplication, the value outside is multiplied times every element inside the matrix. If I'm multiplying a fraction on the outside times a value inside, I am simply multiplying fractions. We are not adding or subtracting. Things to remember: today's get started. Today's date is 10/5. Homework 1.7b is due tomorrow. We will have tutoring tomorrow from 2:30 to 3:30.